Hi, I'm Brian Contos, Chief Security Strategist for Imperva. Today's educational demonstration is on SQL injection. This is part 2, a continuation of SQL injection part 1. So let's just go ahead and stay logged in as bugs and see what else we can do in the system. Let's explore a little bit. Let's take a look at products and let's go ahead and take a look at DVDs, magazines. Now if you look at the bottom of the screen, we see that there's a category ID equal to 4 for magazines, category ID 5 for DVDs, books 1, music 2. So let's take music, for example, and right click. I'm just going to pull up properties. And within this little bar here, I'm just going to copy that. And let's use that as our new URL string. Look at that, I was able to bring up the actual category. Now, nothing really crazy here. It's just the fact that now I can go into this category as well. And if I change this to 5, I get the DVD categories. Well, let's go ahead and see what happens if I change it to 99, for example. Okay, I get a blank page. This is pretty standard. Some sites will give you a redirect, some will give you an error page, some will give you a blank page. There's no error. And part of SQL injection is really generating errors because you can find out, what type of database someone's running, some of the structure. So we know the application showproducts.asp is running these queries. In certain cases, when people write code for web applications, the code will begin and end with an apostrophe. Let's see if we can take advantage of that. Let's put an apostrophe after category ID 99 and see if we can get a nice little error to generate here. And this will cause the error simply because I'm logically sticking an apostrophe in the middle of the code. And it says, okay, I expect one up front, I expect one in the back, something in the middle confuses me. But it also tells us a bunch of stuff. So this gives me a server 500 error. Now I can see that I'm using Microsoft SQL Server, as we can see right here. And it also gives me the syntax I need to use because Microsoft SQL Server will be a little bit different than DB2, that's different than Oracle, etc. So now we know a little bit more about the system. Let's see what else we can manipulate within the URL string. So for example, instead of just 99 with an apostrophe at the end, let's say 99 or our old true statement, 1 equals 1. Let's see what happens. Look at that. Now we're actually able to pull up the entire listing of products name, price, and availability. Not entirely interesting because, you know what, we could have gotten the same information browsing before. So now I want to try a few more things. Let's start looking at some union selects. So this is just going to allow me to start joining some commands together. So we're going to keep the same URL string, but now I'm going to say union select null. That gives me an error again because now we're learning more and more about the system. And by the way, this is one of those things where when you're talking about detecting attacks and you're talking about preventing attacks that are application focused and not network focused, that you run into some problems because a lot of these solutions don't look at the actual URL string, which can make this type of attack difficult to detect. In addition to not looking at that, in addition to what I mentioned before, that there's a whole lot of signatures that you could possibly have to go through, and especially if you look at things like encoding. So signatures might be helpful, but by themselves certainly don't solve the problem. If you're using HTTPS, then your IDS or your IPS or your other systems probably aren't able to look into it anyways, unless you have a system which has the certificate on board and can actually look at the encrypted data. And of course, this is one of the things that web application firewalls can help with in terms of looking at this type of communication. We did this union statement, which again allows me to execute 2 queries. And it did give us an error, but it also gave us some really valuable information that says the operator must have an equal number of expressions in their target list. Okay, well that's actually very helpful. Let's try a couple things. Well, we don't have a even number now, so let's go ahead and make this even and see what happens. Okay, still nothing happening. Not very interesting. Instead of 2 nulls, let's try 4. Okay, that's not working. Let's try 6. And this is where persistence becomes very important when doing SQL injection. Look at that. When we did 6, it actually gave us some interesting information. Now we know a little bit more about the structure of the database. So at this point, I pretty much know that anything that this user Bugs B has permissions to do, I'm going to have permissions to execute those through this SQL injection. And I happen to know that Bugs B is actually an SA, which in Microsoft SQL is an administrative user. You might say, well, wow, why would they have a regular user as administrative user? Well, most people out there that have been doing this for a while knows that you'll actually see production databases in very large companies often that actually let users manipulate data. They're actually set as administrators as the default. Now, these are very bad coding practices, but it does happen. Now, this user doesn't need to be DBA level necessarily. You just need to find a user that actually has the permissions which you need to execute the attacks. Now we can try to do some really interesting things. I've identified which ones are alphanumeric, perhaps which ones are integers. And once you do that, you can really start guessing at the table names and other names. For example, I'm going to guess that one of the fields is going to be name, and another one's going to be credit card number. And again, there is some guessing to this, but let's go ahead and replace some of these null characters. Let's take, for example, the second null character. And instead of saying null in this case, we're just going to go ahead and replace this with the name username. And let's take the second null character, and we're going to go ahead and replace that with credit card number. And I'm also going to tell it that I want to select this from users table. And let's see what we get here. So under category, we get product name, but as you can see, those aren't product names at all. Those are actually the usernames. And under price, we're actually getting some really interesting string, $sign and a decimal and a plus sign. Those are actually credit card numbers. They're not generally displayed in a way that looks like a credit card number to you or me. This is one of the reasons why when you're watching information extruding from an application and or a database, you can't just look for things that match, for example, what you expect a 16-digit credit card number to look like, because they do not always look like that. And we've had to do a slight bit of guessing, not really that much to be honest, especially at the names of some of these fields like username and credit card number. And in fact, these days, when there's such a concern about malicious insiders or partners or contractors or consultants, people that might have in-depth knowledge of these systems that are either currently or have worked for your organization, there's probably a pretty good chance that they're going to, remember what these fields were called when they're trying to launch an attack against you. And it's not as simple as saying, hey, we fired Bob, go ahead and change all the passwords on the routers. You're actually talking about the structure of the database, which is far more complex. But what's a SQL injection attack without some passwords? So let's go ahead and change username up here to password and see if we can pull that. Everything else is going to stay the same. Find category ID, but I'm doing my union select. I've got my nulls in there. I'm saying give me the password and the credit card number from users. And now look at this. Now we actually have all the passwords from these users, a lot of very bad passwords like 1, 2, 3, 4, 5, 6. Users using their username as their password, very common. And we've got their credit card numbers. For more information on Imperva and how to mitigate these attacks, please visit imperva.com. Also be sure to check out our blog, our podcast on iTunes, our other videos on YouTube, and follow us on Twitter.